In this video, we're going to go through the second type of projectiles at a given angle. So let's take the first example. A particle is projected from a point O with speed v meters per second and at an angle of elevation where tan theta is 4/3. The point O is 42.5 meters above a horizontal plane. The particle strikes the plane. The particle strikes the plane at a point 5 seconds after it is projected. Part A, show that v equals to 20, and part B states, find the distance between O and A. So the first thing we ought to do in any mechanics question is to draw a diagram. So we're going to do that. So we know it's starting off from a plane. This is the origin here, and then it's projected with a speed of v meters per second, and I'm going to do this, and then the projectile goes like that. Now I'm going to draw the horizontal distance like so, so we can actually visualize what's actually happening here. So then what we ought to do is to draw in the angle. That's what we did in the previous video. So it's the angle theta, and then we're going to resolve the velocity into its horizontal and vertical components respectively. So let's draw the horizontal components. Let's draw the vertical component. So that's going to be v cos theta and v sine theta. So we've got our components written in like so. Now we also know that this is 42.5 meters as it's given to us in the question, and that this is the point A, and that we know that the horizontal displacement is going to be x meters, as so. So we want to show that v is 20. So we can do that by doing a suvat, and we're going to take upwards as positive. So for part A, we're going to take upwards as positive. We're going to do a suvat. So A must be minus G. Now in our case, that's v sine theta. Now be careful that it's 42.5 meters below the point of projection, where O is the origin. So that's going to be minus 42.5 meters because it's below the origin. So that's important in suvat, so especially in projectiles. So we're going to write that as minus 42.5. Now, if we go back to the question, we also notice that it's 5 seconds, so we need t is 5. So the suvat formula we're going to use is S equals ut plus a half at squared. So in our case, it's minus 42.5 v sine theta, now t is 5, minus g over 2 is going to be 4.9. That's half of g. So I'm going to write g over 2 first and then multiply that by 5 squared, which is 25. Now, don't forget, they've given us a result that tan theta is 4/3. So we can say that that means it's opposite over the adjacent side. So that must be 5. So we can say from here, sine theta is going to be 4 over 5. Cos theta is going to be 3 over 5. So now we can replace that here. So we can say minus 42.5 is going to be v times 4/5 times by 5 minus 4.9 times, which is half of g, times 25. I'll just write the 4 a bit more clearer. So the 5 and 5 cancel out. So if we rearrange that, we should get the result required. So we should get 4v is equal to 4.9 times 25 minus 42.5. And now we should be able to divide it. So v is 4.9 times 25 minus 42.5, all divided by 4, like so. We can type that onto our calculator, and let's see what we get. 4.9 times 25 minus 42.5 over 4, and that gets me the result 20 as required. Then part B says to find the distance OA. So notice that OA is going to be the distance like so. So if I draw that in, it's this distance here, which seems to form a right angle triangle. So we know what the height is, that's 42.5. Once we know what x is, then we can use Pythagoras to work out this hypotenuse of a right angle triangle, which is OA. Now part B says we need to work out this hypotenuse OA of a right angle triangle. So we know the height is 42.5, and we need to work out what x is. Well, we can do what we did in previous videos by working out the horizontal displacement. And if you recall, I said to you that that was s equals ut. So in our case, we've got the time of flight, which is 5. So in our case, it's going to be u cos theta. So it's going to be, or in our case, v cos theta, because in our case, u is v. So we know what v is. V is 20, so it's 20. Now, don't forget, so actually what I'll do is I'll write the full working out clearly so you can see what that is. So I'm going to write v cos theta times 5. Because u in the horizontal direction, as in the horizontal component of velocity is v cos theta, I'm going to multiply that by the time of flight, which is 5. Now, we know what v is, we worked that out to be 20. We know what cos theta is, we worked that out to be 3/5, and we're going to times that by 5. So that gives me that the horizontal displacement is going to be 60 meters. So now we can use Pythagoras to say that to work out OA, we're going to do 42.5 squared plus 60 squared and square root it. So let's do that. So therefore, OA is 42.5 squared plus 60 squared. Now just remember, even though as a displacement is minus 42.5, we're working out the distance. So it's the distance of a length of a triangle, so we're treating it as 42.5. So it's 42.5 squared plus 60 squared square rooted, and we're going to round our solution to 3 significant figures. So let's move my calculator here. So that's the square root of 42.5 squared plus 60 squared, and that's going to give me 73.5 meters. And that's been rounded to 3SF, or 3 significant figures. Here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. A ball is projected from a point A on level ground with speed 24 meters per second. The ball is projected at an angle of theta to the horizontal, where sine theta is equal to 4/5. The ball moves freely under gravity until it strikes the ground at a point B. Find the time of flight of the ball and the distance from A to B. So let's, as what we always do in mechanics, is draw a diagram. So we're going to do that. So it's a particle or a ball being projected from point A. So here's the point A, and it gets projected, and here's our projectile to some point B here. So we can draw in our horizontal distance here, and we know that it's projected with a speed of 24 meters per second, the angle of theta. Let's resolve our velocity component horizontally and vertically. So that's 24 cos theta, 24 sine theta. Now we want to find the time of flight. So let's do a suvat taking upwards as positive. A must be minus G. It starts from the origin. There's an O is here, and it comes back to the origin. Starts from 0 and ends at 0. So S is 0. U vertically is 24 times sine theta. But we know what sine theta is, so we can say 24 times 4/5. And that's everything that we have. So we can say that the suvat equation we're going to use for part A is S is ut plus a half at squared. So it ends up at 0. Now u is 24 times 4/5 of t minus g over 2 times t squared. So we can factorize that to give me, so we end up with 24 times 4 over 5 minus g over 2t. Now we can solve that to give me, well, t equals 0. The particle is obviously at the origin. So the other value is 24 times 4 over 5 minus g over 2 t equals 0. We can solve for that. G over 2 t is 24 times 4 over 5, and we're just going to divide it by 4.9 essentially. So t is this value, 24 times 4 over 5 divided by 4.9. So we can work that out on our calculator. So let's move my calculator over here. So we get 24 times 4 over 5. Get the answer, and we can divide that by 4.9. And that was going to give me 3.92. The 3 significant figures. I'm going to store that in A just in case we might need that later. So let's see what the next part of the question says. It says to work out the distance A to B. Now, so if we have what sine theta is, so we can draw our triangle out here. So we've got theta. They've told us that sine theta, if we go back to the question, was 4/5. So that's going to be 4 and 5. So it's Pythagorean triangle again. So we can say sine theta is 4 over 5. Therefore, cos theta is 3 over 5. So we want to find the horizontal displacement. So that's going to be part B. Horizontally, it's going to be S equals to U times T. Now we know what T is, so it needs to be the true value of T. So in our case, it's going to be 24 times 3/5. So 24 times 3/5 times by the true value we had for T. So the answer 3.918 and so on. And we're going to times it by 24 times 3/5 times 24 times 3/5. And that gives me 56.4 meters. Correct the 3 significant figures.